Well, fourth time is the charm on this video, I sure hope. In the last video, we went over all these properties of quadrilaterals, and in this video, I'm just going to go through the examples. If you need a few examples of what you're looking for as you move into your notes and how to use these properties. So, language is really important, and then understanding those identities of the specific quadrilateral it's identifying. So let's look at each of these examples. Example 1 says use the information in parallelogram. Again, it's important, it's telling you it's a parallelogram, so even though those markings are not on here stating they're parallel, we're given that in the problem. A, B, C, D to determine, and then a few of these measurements it's looking for. Really quickly, I don't know if I already talked about this in a video, can't remember, but A, B, C, D. So whenever we define a polygon, and it lists the vertices, we always move in clockwise order when we're labeling them. So we would go from A to B to C to D. It seems kind of intuitive for me, at least, to go A, B, and then C, D. So just remember, we always move in a clockwise direction, no matter which vertice we start on when we're creating our own diagrams. Okay, so we want to determine a few things. The first one is the measure of BAD. The next one is going to be the measure of angle ADB, so I'm just writing what they gave us at the top. We're then looking for length AT and length BD. So let's remember about the angle properties. So if it's asking us to find BAD, that would be from B to A to D, so we're looking at this one right here. B to A to D. Now remember, angles that are opposite each other are equal. So we know that this whole angle over here is 80 degrees because this one's 80 degrees. And remember the consecutive angles, so if they're next to each other, these two, they're going to be supplementary. So if this one's 80 degrees and they need to add to 180 degrees, then this angle over here must be 100 degrees. So angle BAD is going to be 100 degrees. The next one, the measure of angle ADB, so A to D to B. Now again, if we know this whole thing is 80 degrees, a piece of it is 32 degrees, then we can just take 80 degrees, subtract out the 32 degrees to figure out that ADB, which is just a part of that angle, would be equal to 48 degrees. Length AT, so notice AT goes from here to here, it's half of a diagonal. And diagonals, right, bisect each other, so if this side is a certain value, so is this side, so if that's 7, this side is also 7. B to D, again, here's B going all the way to D, so this is a full diagonal length. If half of it's 10, then the other half is also 10, so 10 plus 10 would give us a full length of 20. Awesome, so that's a parallelogram. Jumping to number 2, it says using a given rhombus. So rhombus is even more specific. It says where measure of angle SPR is 35. So that's already on our diagram, it's just hard to tell. That's the one it looks like it goes with. 6 also goes with this length right here if you're confused. So in a rhombus, let's see, it wants us to determine R to Q, then the measure of angle SPQ, the measure of angle STR, and the length R to T. So remember, in a rhombus, all the sides are the same length. Let's just think about a few things here. Yeah, all these sides, right, are going to be the same length in a rhombus. They're diagonals. They cross at a 90-degree angle, so they're perpendicular. Diagonals cut angles in half, so if that top one's 35, this other side is actually also 35 degrees, as are the ones that are down here, right? It cuts those in half, so we're looking at 35 degrees all the way around there. And then those are just a few of the things we can determine. So let's look at what it's asking. R to Q, so we're going from R to Q. Again, all sides lengths on a rhombus are equal, so if this one's 7 up here, this one's also going to be 7. Measure of SPQ, so we're going from S to P to Q, so it's that whole angle on the top, and we just talked about if this is 35, this is also 35, so if we add those together, that would give us 70 degrees. The measure of angle STR, so S to T to R, we're looking at would be 90 degrees because those are perpendicular, right? All the diagonals are crossing at a 90-degree angle. And then lastly, R to T, so we've got R up to T. Remember, if this top half of the diagonal is 6, so is this bottom half, because a rhombus is a parallelogram, and their diagonals are bisecting. Awesome. Example 3, so I'm going to scroll down a little bit here. Example 3 says, given that Q and R are midpoints in the trapezoid, determine, and then it's giving us measure of angle QMN, the measure of angle QRN, and the measure of angle QR. Now remember, in a trapezoid, we look at this guy and it told us that this is a mid-segment in the middle because it's hitting the midpoints, meaning this QM is equal to PQ, and these might not be equal over here, right? But they're equal to each other, so NR would be equal to RO. So this creates that mid-segment there in the middle. Remember, these are a set of parallel sides, so this guy over here acts like a transversal going through a bunch of parallel lines. So this is parallel to the mid-segment, which is parallel to the base. So if this angle P is 60 degrees and it's a transversal, this corresponding angle is also 60 degrees. Same thing on the right side. If that's 70 degrees at the base, this one's also 70 degrees up here. So we can find each of those angles. So let's look at it. It's asking us to find angle QMN. So Q to M to N is this angle here up at the top. Now again, this angle up at the top, right, is going to correspond to this angle right here. These are linear pairs. So if that's 60 degrees, 180 minus 60 is 120. So these angles are 120 degrees. The measure of angle QRN, so Q to R to N. We just talked about that. These are corresponding angles. So if that base angle is 70 degrees, this one's also 70 degrees. And then lastly, I accidentally wrote the measure of QR. Whoops. QR is a length here. So QR is that mid-segment in the middle from Q to R. So remember, the mid-segment is just the average of the two bases around it. So in the front, we had the formula that looked like the sum of the bases times 1/2. But it's just an average. So we take 5 plus 8. We divide it by 2 to find half, and 13 divided by 2 is 6.5. Okay. Example 4. So this one doesn't give us a diagram. It tells us that angles J and angle K are consecutive angles in a parallelogram. So we do know it's from a parallelogram, and they're consecutive angles, right? That's really important. Because consecutive angles, they're supplementary, or in other words, they add to 180 degrees. So we know that the measure of angle J is 3x plus 7, and K is 5x minus 11, and we're going to determine the measure of each angle. So again, I don't know the x value, so I probably need to find the x value so I can determine the length or the measure of the angle. I know they're consecutive, so these two angles should add to 180. So I'm going to set up an equation. 3x plus 7 is equal, it's not equal, plus, because there's sum, 5x minus 11 should add up to equal 180. Solving that, we end up with 8x minus 4 is equal to 180. Add the 4 over, we get 8x is equal to 184. Divide by 8, it looks like x is equal to 23. Now we're going to ask us to find the angle measures. So then you're going to say, well, measure of angle J is equal to 3x, and we know the x now is 23 plus 7. So if we go ahead and do that, right, we multiply 3 times the 23, and then we add 7, we end up with 76 degrees. So the measure of angle J is 76 degrees. Then the measure of angle K, you can either plug x in, or remember those are supplementary. So if you want to just take 180 and subtract 76, you're left with 104 degrees. All right, on to the last two. Example 5. For any square JKLM, is it always or sometimes true that JK is perpendicular to KL? Explain your reasoning. For this, I am going to draw a little diagram just to help us kind of see what it's asking. So it says for any square. That's important because we know that these features are true. All the side lengths are the same, and their angles are 90 degrees. Is it always or sometimes true that JK, so I'm going to label that JKLM. Oops, that's the M. So is JK always perpendicular to KL? Well, yeah, if we draw a little diagram there, we see that the 90-degree angle sits right there. And this would always be true, right? Because angles, sorry, my hand is moving things around. This is always true, right? Because two adjacent sides in a square meet at a 90-degree angle, or are perpendicular. or a square has all four right angles, something along those lines. Next one, for any rectangle EFGH, so again I'm going to draw a little rectangle EFGH just to get a handle on what we're looking at here. Is it always or sometimes true that FG, so here's my FG side, is congruent to GH? So looking at the diagram I just drew, hopefully we conclude that it's not always true, but it can be true, right? If we were to squish that rectangle until it became a square, then we would be looking at those two congruent pieces. So this one we would say is sometimes true, and this would be true. FG is congruent to GH when EFGH is a square. Lastly, a quadrilateral has four congruent sides and four congruent angles. Sketch the quadrilateral and classify it. So if it has congruent angles, that means they all have to be 90 degrees if it's a quadrilateral, and if all their sides are the same, then we just created a square. Okay, last one. The diagonals of a square. So again, dealing with a square one more time. LM and P. So I'm going to draw a little diagram of it over here. LM and P. Remember, we go around clockwise. It's a square, so I'm going to put some 90-degree marks there and then go with congruent sides. And it says the diagonals of the square, so I'm going to draw in some diagonals. They intersect at point K. So this is going to be K. Given that LK is 1, so L to K is equal to 1, determine the indicated measures. So let's go through this and look at this. So the first one is measure of MKN. So M to K to N. Now remember, a square is a specific rhombus, and the rhombus, the diagonals are perpendicular. So in a square, it's the same idea. This is a right angle, so this is equal to 90 degrees. Letter B, the measure of angle LMK, L to M to K. Notice this is a corner angle over here. And remember that in a rhombus, diagonals bisect the corner angles. So if this whole thing is 90 degrees, then half of that would be a 45-degree angle. Looking at KN, so going from K to N, K is in the middle, N out here, so just a piece or half of the diagonal. If the other half is 1, then K to N is also equal to 1. The measure of LPK, so L to P to K, is this angle over here. Again, if this one's 45, right, this one's also half of that 90-degree angle. It's also 45 degrees. L to N, so if we're going here to here, that's the full diagonal. So if half of it was 1, the other half was 1, then total that would be equal to 2. And lastly, we have MP, which is the other diagonal. And remember, the diagonals in a rectangle, which a square is a special case rectangle, they are equivalent, so it's also equal to 2. Again, your focus today as you work through the assignment is that you're able to understand the notation correctly and use the notation, as well as apply the properties correctly. So it comes with practice and just identifying the different shapes and their different